We're going to look at another form of a transformation known as a reflection in Lesson 74. And a reflection is an isometry, and if you remember what an isometry is, it's just a pre-image that moves to a new image spot, but it keeps the same size and shape. So we got a triangle here. It's going to be reflected, and you'll see what a reflection looks like. You can probably imagine, but it's going to keep the same size and shape, but the shape will simply be moved, and in this case, reflected is the form of transformation that we're going to use. So, in example 1, and you kind of just got formulas for reflections, but in example 1, it gives us A, B, C at these coordinates, and it wants us to reflect across the y-axis. So this is our y-axis, so we want to reflect across the y-axis. So how do we do that? Well, you actually just kind of got to know the formulas here, or how to translate these images. So the transformation of x, y, meaning our original coordinates, so these are our original coordinates, put x, y here, those are our pre-image, is going to be transformed or reflected by using negative x, y, when we are flipping across the y-axis. So it's very simple. All we're going to do is, in the coordinate 7, 6, if we're going from original 7, 6, and all we need to do is make the x negative, well then, this is going to be negative 7, positive 6. And that's all you're doing when reflecting across the y-axis. So B, you got negative 2, 3. Well, if we got to reflect it, and if x has to be negative, we're going to end up having a negative, double negative, so that makes it a positive 2. And then we keep the y the same. Got a negative 7 here, so that becomes a positive 7. And you keep the y. And then we graph, notice my primes, I put little prime signals, or tick marks by each of them. I'm probably going to run out of room here, but I'll try to graph it. Negative 7. Oh, sorry. This was actually a negative 7, so this should be a positive 7. My bad. Had my coordinates originally mixed up. So this is actually a positive 7, 6. That's right there. Positive 2, 3. These are in increments of 2, by the way. And then positive 7, so here's 7, 1. So there's our new triangle. I label it A, B, C, and I put my prime, so there is my pre-image, and there's my new image. Notice it's simply reflected across the y-axis. So if you had to guess at what would be reflect across the x-axis, if you're reflecting across x-axis, well, if you start with xy, all you do is go to a x, negative y. That's all. So it just switches kind of the places there. So that's how you translate just across x or y axis. Now let's look at if it has you translate across something different. Try to get the glare out of the way. Yeah, that'll have to work. All right. Example 3 wants us to reflect across the line y equals x. That is a line. That's still y equals mx plus b. It just has no b, so the origin is 0. And then if x has no number attached to it, it's just a slope of 1, 1. So this right here is actually the line y equals x, this dotted line. The way you transform or translate across or reflect across y equals x is you have your original xy and you simply switch the places. So xy becomes yx. So we have our coordinates here, and I labeled them here. So negative 3, 5, just to show one up here. all we have to do is switch the 5 and -3. So J would be 5, -3. And then I do that for all the other ones. So this would be 8, 0, 5, 3, 1, 0. Simply flip all the X's and Y's. And then if I'll go ahead and show it to you. Once again, these are increments of 2. There's J, K, 8, 0, L, 5, 3. That's somewhere up there. Kind of. My Y equals X line is not very good. It should be actually a little more angled. And then M is 1, 0. There's my translated image. 5, -3. There's J, K, L, M. And so that's reflected across the line. Y equals X. And those are some formulas that you'll have to use. It might throw different stuff at you, but overall, those are the basics of how you do reflecting when using a coordinate grid.